Imagine staring into the night sky, a canvas of twinkling stars, each a silent witness to the universe's deepest secrets. For centuries, humanity has gazed upward, piecing together the story of our cosmos, believing we've cracked the code of its grand design. But what if everything we thought we knew was teetering on the edge of collapse? What if the universe itself is hiding a truth so shocking, so profound, that it could rewrite the very laws of reality? Buckle up, because the James Webb Space Telescope, humanity's most powerful eye into the cosmos, has just uncovered something so strange, so unsettling, that a Nobel Prize-winning scientist is sounding the alarm. This isn't just another discovery. It's a cosmic bombshell that's shaking the foundations of everything we believe about the universe. Picture this: a telescope so advanced it can peer back nearly 14 billion years to the dawn of time itself, capturing light from the first stars and galaxies that ever formed. Since its launch, this marvel of human ingenuity has been rewriting the rulebook of cosmology. It's spotted galaxies so massive, so luminous, and so impossibly developed that they shouldn't exist in a universe as young as ours. These cosmic giants, glowing brightly just a few 100 million years after the Big Bang, are like finding a fully built skyscraper in a prehistoric village. They defy every model, every theory, every calculation we've relied on to explain how the universe grew from a fiery spark into the vast expanse we see today. But hold on, because the telescope's latest revelation isn't just about oversized galaxies. It's about something far more disturbing, something that strikes at the heart of our understanding of reality itself. For decades, scientists have built their view of the universe on a single, unshakable idea. The cosmos is uniform. No matter where you look, up, down, left, right, the universe should look the same. Galaxies, stars, and cosmic forces should be spread evenly, like a perfectly mixed batter. This idea, known as the cosmological principle, is the bedrock of modern astronomy. It tells us the universe has no center, no edges, and no preferred direction. It's why we believe the Big Bang happened everywhere at once, why we assume the laws of physics work the same whether you're standing on Earth or floating in a galaxy billions of light years away. This principle has guided every major discovery, from the expansion of the universe to the faint glow of the cosmic microwave background, that ancient echo of the Big Bang itself. But now, the James Webb Space Telescope has thrown a wrench into this cosmic machine, revealing evidence so explosive it could tear this principle apart. Take a deep breath, because here's where things get wild. A groundbreaking study, published on February 6, 2025 in the astrophysical journal Letters, has dropped a bombshell that's sending shockwaves through the scientific community. Using the telescope's razor-sharp infrared vision, astronomers have discovered that the universe's expansion, the very force stretching the fabric of space itself, isn't happening the same way everywhere. That's right. Depending on where you point this telescope, the universe is expanding at different speeds. In some regions, galaxies are racing apart faster than expected. In others, they're moving more slowly. This isn't a minor glitch. It's a cosmic crisis. If the universe isn't expanding uniformly, everything we've built, from our estimates of the universe's age to our predictions about its future, could be fundamentally flawed. To grasp just how earth-shattering this is, let's rewind to 1929, when an astronomer forever changed our view of the cosmos. Using the most powerful telescope of the time, he noticed something astonishing. The farther a galaxy was from Earth, the faster it was speeding away. This wasn't random motion, it was proof the universe itself was expanding, like a balloon inflating with every passing second. This discovery gave birth to the idea of the Big Bang, the moment when all matter, energy, and space erupted from a single point. By measuring how fast galaxies are moving apart, scientists could calculate the universe's expansion rate, a number called the Hubble constant. This number is the key to everything. It tells us how old the universe is, how big it is, and what forces are shaping its destiny. For nearly a century, we've assumed this expansion is uniform, happening at the same rate in every direction. But the James Webb Space Telescope is now screaming at us, we might have gotten it all wrong. Here's where the plot thickens. To measure the Hubble constant, scientists used two main methods, and for years, these methods have been at war with each other. The first method looks at the cosmic microwave background, that faint glow left over from the Big Bang. It's like a snapshot of the universe when it was just 380,000 years old, a baby in cosmic terms. By studying tiny ripples in this radiation, captured by satellites like Planck, between 2009 and 2013. Scientists calculated a Hubble constant of about 67 kilometers per second per megaparsec. In plain English, that means for every 3.26 million light-years of distance, galaxies are moving apart 67 kilometers per second faster. Sounds precise, right? But hold on, because the second method tells a completely different story. This second approach uses stars called Cepheids, cosmic lighthouses that pulse with a predictable rhythm. Their brightness and pulsation rate act like a ruler, letting astronomers measure distances to faraway galaxies. By comparing how bright these stars appear to how bright they actually are, scientists can calculate how fast those galaxies are moving away. This method, refined by the Hubble Space Telescope and now supercharged by the James Webb, consistently spits out a higher number, around 74 kilometers per second per megaparsec. That's a gap of about 7 kilometers per second per megaparsec. A difference so big it's like measuring your house with two rulers and getting two wildly different results. For years, scientists hoped this discrepancy, dubbed the Hubble tension, was just a measurement error, a glitch in our cosmic yardstick. But the James Webb Space Telescope has slammed the door on that hope. With its unparalleled clarity, the telescope has double-checked the Hubble Space Telescope's work, peering through cosmic dust and isolating Cepheid stars with surgical precision. The results are undeniable. The higher expansion rate is real. No errors, no mistakes. The universe is expanding faster in some places than others, and nobody knows why. A Nobel Prize-winning astronomer, one of the sharpest minds in cosmology, has called this not just a problem, but a full-blown crisis. This isn't about tweaking a few numbers, it's about questioning the very rules that govern the cosmos. If the universe isn't uniform, if its expansion is patchy, then the cosmological principle, the foundation of everything we know, is crumbling. And with it, our understanding of the universe's past, present, and future is hanging by a thread. Let's pause for a moment to feel the weight of this. Imagine you've spent your life believing the ground beneath your feet is solid, only to find out it's a patchwork of shifting plates. Some moving faster, some slower, some not moving at all. That's what this discovery feels like for astronomers. The universe, which we thought was a predictable, orderly place, is suddenly chaotic, unpredictable, and full of mysteries we can't yet solve. One possible culprit: dark energy, the mysterious force driving the universe's accelerating expansion. Discovered in 1998, dark energy is thought to make up about 68% of the universe, yet we know almost nothing about it. What if dark energy isn't spread evenly? What if it's stronger in some regions, weaker in others, creating pockets where the universe expands faster or slower? If true, this would mean the universe isn't just non-uniform, it's fundamentally uneven, with forces acting differently depending on where you are. This idea is both thrilling and terrifying. Thrilling because it opens the door to new physics, new discoveries, and a deeper understanding of the cosmos. Terrifying because it means we might need to rewrite the laws of physics themselves. If the universe isn't isotropic, if it doesn't behave the same in all directions, then everything from gravity to the speed of light could vary across cosmic scales. Beyond the observable universe, the rules we take for granted might break down entirely. Imagine a cosmos where gravity pulls harder in one direction, where light travels slower in some regions, where the impossible becomes possible. This isn't science fiction. It's the reality the James Webb Space Telescope is forcing us to confront. But the telescope's revelations don't stop there. Beyond the Hubble tension, it's uncovering other cracks in our cosmic model. Take early galaxies, for example. Current theories say it should take billions of years for gas and dust to coalesce into massive star-filled galaxies like our Milky Way. Yet the telescope keeps finding these cosmic behemoths in the universe's infancy, just 200 to 400 million years after the Big Bang. These galaxies aren't just big. They're packed with stars, some so old they challenge the timeline of the universe itself. One study found 87 such galaxies, glowing brightly when the universe was just 290 million years old. That's like finding a teenager running a Fortune 500 company. It shouldn't be possible, yet there they are, staring back at us through the telescope's lens. These findings are more than puzzles, they're existential challenges. The standard model of cosmology, called lambda cold dark matter, or lambda CDM, is the best explanation we have for how the universe evolved. It accounts for the Big Bang, the formation of galaxies, the distribution of matter, and the role of dark energy and dark matter, those invisible forces shaping the cosmos. But this model assumes a uniform universe with consistent expansion and predictable galaxy formation. If the telescope's observations are correct, if galaxies form too fast, if expansion rates vary, if dark energy is uneven, then lambda CDM might be fundamentally flawed. Some scientists are even whispering a radical idea. What if the Big Bang itself isn't what we think? What if the universe didn't have a single starting point, but is something stranger, something beyond our comprehension? Feel the goosebumps yet? This is the kind of discovery that keeps astronomers awake at night, staring at the ceiling, wondering if they're on the brink of a revolution or a cosmic dead end. The James Webb Space Telescope isn't just showing us stars and galaxies. It's showing us how little we truly know. Every image, every data point is a challenge to our arrogance, a reminder that the universe is vast, complex, and full of surprises. But it's also a call to action. Scientists are racing to analyze this data, to build new models, to test wild theories. Some propose that dark energy might evolve over time, growing stronger or weaker as the universe ages. Others suggest exotic particles or primordial magnetic fields could explain the discrepancies. One bold idea even posits an early form of dark energy, a cosmic kick that gave the universe an unexpected boost right after the Big Bang. For the average person, this might feel distant, like a debate among eggheads in ivory towers. But think about what's at stake. The universe is our home, the only one we've got. Understanding its rules isn't just academic. It's about knowing our place in the grand scheme of things. If the universe isn't uniform, if its laws vary, then our story, our origins, our future all come into question. Are we a fluke, a tiny speck in a chaotic cosmos? Or are we part of something bigger, something we're only beginning to glimpse? The James Webb Space Telescope is our guide, our torch in the cosmic dark. And right now, it's illuminating a path filled with wonder, fear, and possibility. Let's zoom in on one of the telescope's most jaw-dropping images, a galaxy called JWST 13, the farthest ever seen, shining when the universe was just 290 million years old. This isn't just a smudge of light. It's a time machine, carrying photons that have traveled 13.5 billion years to reach us. Its brightness, its structure, its sheer existence defy everything we thought possible. According to our models, galaxies like this shouldn't form so quickly, yet there it is, mocking our assumptions. And it's not alone. Dozens of similar galaxies, scattered across the early universe, are forcing scientists to rethink how stars and galaxies come together. Were the conditions after the Big Bang wildly different than we thought? Did some unknown force supercharge galaxy formation? Or is our timeline of the universe itself wrong? Now imagine the scientists poring over this data, their hearts racing as each new observation upends years of work. Picture the late-night debates, the scribbled equations, the moments of awe and frustration. One astronomer, a leader in the field, described the feeling as standing on the edge of a cliff, staring into an abyss of the unknown. Another said, it's like solving a puzzle, only to find half the pieces belong to a different picture entirely. These aren't cold, detached researchers, they're humans, grappling with the biggest questions of existence, driven by a hunger to understand, and they're not alone. Across the globe, people are tuning in, captivated by the idea that we're on the cusp of a cosmic breakthrough. The emotional weight of this discovery can't be overstated. For centuries, humanity has sought meaning in the stars. Ancient civilizations built myths around constellations, seeing gods and heroes in the night sky. Philosophers pondered whether the universe was infinite or finite, eternal or fleeting. Scientists like Einstein and Hawking wrestled with its laws, each discovery bringing us closer to truth, but also revealing new mysteries. Now, the James Webb Space Telescope is carrying that torch, and its light is exposing a universe stranger than we ever imagined. It's humbling, exhilarating, and a little scary. We're not just learning about galaxies or expansion rates, we're confronting the limits of our knowledge, the fragility of our assumptions, and the infinite possibilities of what lies beyond. But here's the kicker. This crisis in cosmology isn't a dead end. It's a beginning. Every major leap in science has come from moments like this, when the old models crack and new ideas rush in. When Galileo turned his telescope to the heavens, he shattered the idea that Earth was the center of everything. When Einstein proposed relativity, he upended our understanding of time and space. Now the James Webb Space Telescope is sparking a revolution of its own. The Hubble tension, the massive early galaxies, the non-uniform expansion, all these anomalies are clues, breadcrumbs leading us toward a deeper truth. We may not have the answers yet, but the questions themselves are electrifying. They remind us that the universe is alive, dynamic, and full of secrets waiting to be uncovered. So what does this mean for you, watching this unfold from your corner of the world? It means you're witnessing history. You're alive at a moment when humanity is rewriting its cosmic story, when a single telescope is challenging centuries of thought. It's a reminder to stay curious, to embrace the unknown, to marvel at the audacity of our quest to understand the infinite. The universe isn't just out there, it's part of you. The atoms in your body were forged in ancient stars, your existence tied to the same forces shaping those distant galaxies. When the James Webb Space Telescope peers into the cosmos, it's not just exploring the universe, it's exploring us. As we speak, astronomers are planning new observations, hoping to confirm or refute these findings. Future telescopes, like the Nancy Grace Roman Space Telescope, will join the hunt, mapping the universe with even greater precision. Every new image, every new measurement brings us closer to unraveling this cosmic enigma. Will we discover a new form of dark energy, a flaw in our understanding of gravity, or something so wild, so unexpected, that it redefines reality itself? The possibilities are endless, and that's what makes this moment so thrilling. We're not just spectators, we're explorers, standing at the edge of the known universe, ready to leap into the abyss. So the next time you look up at the stars, let your mind wander. Picture those ancient galaxies glowing in the dawn of time. Imagine a universe where the rules bend, where the impossible becomes real. Feel the awe, the wonder, the electric pulse of discovery. The James Webb Space Telescope has shown us that the universe is stranger, wilder, and more mysterious than we ever dreamed. And in that mystery lies our greatest opportunity: to question, to explore, to redefine what it means to be human in a cosmos full of surprises. This is our story, our adventure, our chance to touch the infinite. And it's only just begun. Let's dive deeper into the heart of this cosmic drama, because the stakes couldn't be higher. The non-uniform expansion of the universe isn't just a quirk, it's a direct challenge to the very principles that have guided cosmology for a century. The cosmological principle, that idea of a uniform universe, isn't just a convenient assumption, it's the glue holding our models together. Without it, calculating the universe's age becomes a guessing game. The Big Bang Theory, which has been the cornerstone of cosmology since the 1960s, relies on the idea that the universe expanded evenly from a single point. If that expansion is patchy, if some regions are stretching faster than others, then the entire timeline of the universe, from the first stars to the formation of galaxies like our own, could be wrong. This isn't the first time the James Webb Space Telescope has stirred the pot. Since its launch on December 25th, 2021, it's been delivering one shock after another. Its infrared eyes, capable of piercing through cosmic dust and seeing light from the universe's earliest moments, have revealed galaxies that are too big, too bright, and too old for our current models. One galaxy, spotted in the JWST survey, was so massive it would have required star formation at an impossible rate to exist just 500 million years after the Big Bang. Another, GNZ 11, seen 430 million years post-Big Bang, contains an accretion disk that suggests a supermassive black hole, a feature we thought took billions of years to form. These aren't isolated cases. They're part of a growing pattern that's forcing scientists to question whether our understanding of galaxy formation is fundamentally broken. The emotional impact of these discoveries hits hard. Imagine dedicating your life to studying the universe, building models that explain its every quirk, only to have a single telescope upend it all. For astronomers, this is both a nightmare and a dream come true. A nightmare because it means years of work might need to be scrapped. A dream because it's a chance to uncover something truly new, something that could redefine our place in the cosmos. One scientist described the moment they saw the telescope's first deep-field image as like falling in love and having their heart broken at the same time. The beauty of those ancient galaxies, glowing across billions of years, was matched only by the realization that they didn't fit into any known framework. Let's talk about dark energy again, because it's the wild card in this cosmic game. When scientists discovered in 1998 that the universe's expansion was accelerating, they were stunned. The only explanation was a mysterious force, dubbed dark energy, pushing galaxies apart faster and faster. This force, which makes up nearly 70% of the universe's energy, is still one of the biggest unsolved mysteries in physics. The James Webb Space Telescope's findings are raising an intriguing possibility. What if dark energy isn't constant? What if it varies across space, creating regions where the universe expands faster or slower? This idea, called evolving dark energy, could explain the Hubble tension and the non-uniform expansion, but it also opens a Pandora's box of questions. If dark energy isn't uniform, what else about the universe is uneven? Could dark matter, that invisible stuff holding galaxies together, also vary? Could the laws of physics themselves change depending on where you are? This brings us to another mind-bending possibility. The universe might not be infinite. For decades, cosmologists have debated whether the universe goes on forever or has a finite boundary. The cosmological principle leans toward an infinite, uniform universe with no edges or special places. But if the universe is patchy, with different expansion rates and uneven distributions of matter, it raises the possibility of a finite cosmos, or at least one with distinct regions that behave differently. Some scientists are even exploring the idea that our observable universe is just one bubble in a vast multiverse, each with its own laws of physics. This isn't just speculation. It's a serious hypothesis being tested with data from the telescope. The implications are staggering. If we're in a multiverse, our entire understanding of reality, our place in it, our significance, could shift overnight. Now let's ground this in something tangible. The James Webb Space Telescope isn't just a machine. It's a triumph of human ingenuity. Its 6.5-meter mirror, made of 18 gold-coated segments, folds up like origami to fit inside a rocket, then unfurls in space with precision